everybody. In the first escape room that Mark and I ever played, in the last room there was a piano that was not really used in a puzzle, and it would seem like such a waste. So we tried figuring out a way to mechanically make that. It never actually came, nothing came of that one. So on this one, when we're talking to Terror Isle, they weren't real clear on their last final puzzle of one of their games, and they were going to have a pipe organ in the room for when it's in haunted house mode. And for some reason, the puzzle used the pipe organ. So we're getting to do it. We're getting to use the pipe organ. So I guess 3 things I'm going to talk about in this video, or at least babble on. Number 1 is MIDI, which I've never used before, but we have broken into on this one. So that is in lieu of trying to get a mechanical switch read from a piano to here. We're just going MIDI out to an Arduino that's going to read all that stuff. Number 2 is Fusion. I've really gotten into Fusion recently, mostly because SketchUp got expensive and I was already paying for Fusion because of what is now Eagle, blah, 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 blah. It is amazing. So there's been a deep learning curve on this, particularly with modeling this thing in Fusion very accurately so that it fits into this thing very accurately, which it has to do because you can't see all of the nice black Casio tone. It needs to look like a pipe organ, which Mark has already aged and kind of yellowed the teeth. And number 3, this is kind of a minor thing, is odd locks. So this one, we've actually used this already on a couple of puzzles in this series of games. It's a Game Master's lock. I think these are billed as like manager fire door locks or something weird on that one. We found them on Google, but it's basically a little gear tooth thing here that just throws a deadbolt. And this is good for access for Game Masters that players can't get to if you need something there, because we did need to, and I'll go over that in a minute, be able to get this thing into the whole build-up without tearing the whole thing off of the wall. So this actually has 2 different access panels on it. One to swing it up into the bottom, and then one to get to it once it's already in there and plugged in, and all of the guts access. So we probably should have gotten some of this on film before, but it's stained now, about to go together for probably maybe the last time, maybe just the penultimate. But yeah, let's go through this in detail, and we'll talk more about MIDI, Fusion, and these neat little guys. The first key part of it is MIDI. MIDI stands for Musical Instrument Digital Interface. 90% sure I'm right about that. It goes back to the 80s, so it's pretty old, and once I started looking into it, it's kind of simple. Basically, the MIDI instrument, in this case our keyboard, whenever you do anything to it, it puts out a MIDI signal with a couple of different bytes on there that are the kind of signal, the channel it's going on, and then what it's doing with, what we care about is what note is being played. That's actually the only piece of data we care about, not velocity or the attack speed or whatever else is encoded in there. Fortunately, because this is Arduino and I'm not the first one to get a MIDI anything to talk to Arduino, there's a library for this, and it's called MIDI.h. There's a little bit of hardware that you have to rig up. Schematic is here. And pretty much this is just taking the MIDI pins, and you're really only using 2 of these and sending them to the Arduino. There's plenty of good videos out there on MIDI that I watched to learn all this, so rather than badly paraphrase them, I will just let you find those, and maybe if I remember to, actually link 1 or 2 of them. And speaking of seamless segues, we've pretty much always used some kind of CAD program to do our designing. I've had several crappy ones before I found SketchUp, and SketchUp was great for a very long time because it's a good graphic interface and it's kind of what you see is what you get. And then we found Fusion, which there was definitely a learning curve and a kind of a different mental path you have to take in designing something. Primarily because Fusion has time travel mode. So there's a button on here that you can click and go back in time to kill Hitler, if you actually put a Hitler early on in your, which you shouldn't do, but if you do, you can go back and kill Hitler. So the great thing about Fusion, not only is it the same software that I do all of my PCB design with, because Eagle is now Fusion, you can, everything is based off of sketches, so you can go back and then tweak that master sketch or kind of a sub-master sketch depending on how you have it all built up, and that change will propagate out through the whole thing. So if you need to make a dimension different, you don't have to grab each individual face that needs to move and move them, as long as it was set up to where this thing is based on the previous, and you change that first one, it'll propagate through. All this stuff down here, this is my timeline for building up my model of our keyboard. And if I needed to, I'm not gonna mess with this right now because it's good, but if I needed to, I could take one of these and then move it elsewhere in the timeline such that if you did a mirror or a copy on something, you can include or exclude whatever bits happened to the original to the copy, and all sorts of great stuff like that. The other thing for this guy in particular is this curve here is really, really specific. And as you can see, it needs to be very accurate for our keyboard to kind of fit seamlessly into our wooden box and make it look like it's not a modern Casio tone, whatever number you are, CTS 200, that good old one. So we're gonna have that pretty much just a very, very tight tolerance on that one. This is where I probably should have gotten some in-process footage. What I was able to do is push this guy into, into the edge of the profile of the keyboard, and it's got measurements on it. I can then take a picture of that, set it down, and then something Fusion can do is take that picture, scale it to those measurements, and then I know my exact curve because they're a little odd. They're not super, well, they are regular, but they're not easily defined. So I got to use this guy. This is not a paid promotion, but Autodesk, if you wanna, I don't know, just discount one of our licenses, that'd be nice. Talking to you, Lars. So these little guys right here are great, but I have no idea what they're actually called because the only English on here says Hardware Series, and I think that's Taifang with some questionable typography because it looks like Iafang. But I didn't design it, so I shouldn't be a hater. Anyway, they're great. We get them on Amazon, and you've got this little jacks or little kind of gear tooth key. There's a worm gear in there. Stick him in here. Crank that out, you pull this out. So this is nice for Game Master stuff because you only need one of these to get into all of your games. Not everything is a unique key, and players can't really operate these. I'm sure someone has a Swiss Army knife or Leatherman that they will do so anyway, but shame on those players, stop them.
Hey, Matt. That pipe organ thing that you were doing, how's that coming? Seriously? Come on, man. Why?
We got it done.
Yeah, come on. No,
It's not bad for a jump cut.
well, this looks great. I'm glad I had something to do with it.
Yes. This is a real, not fake, true statement. That's one of those things. It's an alternative statement. This is a great example of how 3D modeling can really make things work without having to do too much just trial and error, even though there was some involved in this. Everything fits beautifully. And as far as the hardware end of the electronics bits, having made this guy right here, this is my kind of universal game controller. So I have all kinds of inputs and outputs on this one. It's essentially a glorified breakout board for an Arduino Nano, but with the baseline of code I already have, I can just kind of essentially recycle some bits of codes that are checking your inputs and then triggering your outputs. So you can go from even a more limited version of this guy without all of the pieces on him to make it run this.
Yay! It does stuff.
Fundamentally, the whole organ is actually two puzzles in one, all running through the same system. So in addition to all the nice pretties that we have here, extra hides for whatever needs to go in there, and all the pull stops, which is the first puzzle, the candelabra of Scully Doom. First step is to pull out all the stops in the right order, and that is going to pop that hide. Then you got to play the proper chord sequence, and to give you some feedback on that you actually know what you're doing, the candelabra of doom will extinguish as you slowly banish the ghost.
This took a little bit longer than we expected, but we had a fantastic time with it. I gotta say, I'm happy as heck with how it turned out. I wouldn't normally say that. That would be another word.
Which word is that?
Fudge.
No.
As always, the deep dive stuff is on Patreon. We hope you enjoy these little snippets of what we do, and keep coming back. And show us pictures of what you've done. Join us on Discord. If you're with us on Patreon, we have a Discord server that you can join, and we all talk about the projects we're working on, share ideas, advice, tips, tricks, all that kind of stuff. So hopefully we'll see you there, and if not, enjoy this. I just said no more smoke bombs. That's the note. That's it. That's the chord.
Okay, that's the solution. You're a star, buddy.